So we'll be talking about Amazon SQS or simple queue service. Now, the concept of a queue is that there are two ways, first of all, by which you can send the messages. Actually, multiple ways, but right now we'll talk about two. So one is a way like your HTTP or HTTPS, or wherein you send a request to the server and the server responds back to you. For example, you ask me a question and I answer back to you straight away. That is one way. Now the thing is that you send a request to me, I am processing it, and in the meantime you are waiting for the response. So in this case what happens is that a delay actually happens. So if you are waiting for me only, in the meantime you can perform some other task also, but then because you are still waiting for me, so you cannot perform any other task. Another way to think about this is like this: you send a message via internet to someone, and let's say that they are responding back to you, but while they are responding back to you, the internet is not working in your area. So at that time the internet became dysfunctional. So you have sent a request to the server has responded back to you, but while they were responding back to you, the internet broke down, so you were not able to get any message. So in this case what happens is you will still be waiting, because you will assume that you have to receive the message and the server is awaiting that you should have received the message. So things like this happen in real life also. There is another scenario. Let's take the scenario of a load balancer sort of a thing, where you are sending a request to the load balancer and the load balancer has to send it to any of the instance. So let's say there are three instances. Load balancer sent the request to one of the instance and that instance is not working now. So that message is now lost, because the load balancer is expecting a response back. Now the load balancer, we understand, will eventually remove the machine from the load balancer itself, but that process in itself is going to take some time. So because we don't want that, and we want that while the load balancer is sending the message to the instance or my Lambda function or whatever that thing is, I should it should be in such a way that no loss of the messages happens. So in that case I can take help of something known as a SQS. So SQS is Amazon's integration of simple queue service. However, queue is a pretty old concept. So queue dates back to your JMS, where you had something as Java messaging service. You could push the message to a queue and someone could pick up the message and process the message. That was one way to do it. Second way to do it is you go and push your message to a SQS queue, and some subscriber is going to pick up the message and they are going to process the message and do whatever they are intended to do with the message. Advantage of a queue is that a queue actually has 1 million requests free for each month. So that's quite a big number. So it's pretty interesting use case scenario which is being used nowadays by a lot of people. Now there are multiple ways to think about the use case scenario of queue. Example that is there is, let's say I have to send a SMS to a million people, or I have to send a notification to a million people, or 10,000 people. In that case I can either send the message as it is to 10,000 people, or what I will do is I will push the message to the queue. Now if I have to send a message to someone, email to someone, notification to someone, that at the end of the day is going to be a machine which is going to pick up that message, process the message and send it to the end provider. So let's assume that I have a instance or a machine which gets the request, creates the email out of it and sends it to the end customer. So the input over here is email. So my machine gets the email as input. Based on the email, it gets the username, it gets the address, and it gets the phone number. So it goes into the database, searches for that information and sends it back. So in this scenario, my backend machine gets one email, fetches these three information, combines all of that, creates a beautiful email out of it and sends it to the end customer. So now if you are doing or sending, let's say 10,000 requests to that backend in 1 second itself, there is a very high probability that your backend might crash. So in this case, you might take help. You might say that, okay, if the load on the server is more, I might go for auto scaling in this scenario. In that case, if you are sending multiple messages, your machines will duplicate, and based on that they will process the information, and once it is all done the machine will again go back to one machine. That is a way, yes. However, there is one more way. Now the thing is that, take this scenario, my machine or my backend machine still is just one machine which gets the email and it gets the information, sends it back. The problem is that I am sending 10,000 machines or 10,000 messages to that machine in one shot. Now, to break that, what I will do is, instead of that, I will send the message to a queue. The queue itself will have 10,000 messages stored inside itself for a duration of 4 days. The machine over here will go and tell the queue, I need one message. It goes, picks up the message, processes the message. Once the message is processed, it goes back to the queue and say, I need the next message. Okay, so that's a use case scenario. In this case, let's say if I have to send a message to someone, or I have to send 10,000 messages, now my machine can go and take one message at a time, or it can take 10 messages at a time. So what will happen is, if I have to send 10,000 messages to someone, I am going to pick up 10 messages in 10 seconds basically. So one message in 1 second divided by 60 basically, and you will get to know in how many minutes this will be processed. So that's the reason why you would have also seen that certain applications say that, you will be getting the notification. However, getting the actual thing or the actual PDF or the actual invoice and bill will take some time, because what we do is we send the message to the queue, and some backend machine on its own convenient time is going to pick up the message and send it, or process it in whatever way it has to. So the concept of a queue is, queue becomes a placeholder where it is going to save a message. Now, if you want to think what a message is, a message can be a JSON message, a message can be a text message, a message can be anything for that sake. Okay, though please don't think that you might be sending big files on that message. This is a small message that we are talking about. Like in my case, the example that I gave, we were just sending the email address, a small email address on that machine. Okay, so this is the use case scenario of a queue. Let's get started with a queue finally, and we'll see more details once we are there. So if I go to create a queue, I have two options: a standard queue and a FIFO queue. The difference between the two is that in case of a standard queue, I can go and I Fine. So yeah, in case of a standard queue, if I'm sending 10 messages, AWS will try to send messages in the same order. Like if I have sent 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, AWS will try to respond back in the same way. However, it's not guaranteed. In case of FIFO queue, AWS will guarantee that, if you are sending the message in the sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, AWS is going to send you the messages also in the same order only. So that's the difference between a standard queue and a FIFO queue. Standard queue is cheaper, obviously, because it does not have the FIFO things. So it's cheaper as compared to a FIFO queue. However, based on your requirement, you might want to change between a standard and a FIFO queue. For example, in the finance-based application, you tend to go for a FIFO queue by default. In a secure application or where security is issue, in that case, you go for a FIFO queue most of the time. Okay, so in this case right now I am going for a standard queue anyhow. uh, okay, and I can go and give a name to my queue. So let's say I am giving it something like q1, and my visibility timeout, basically it means the message is going to remain in that much time only, and my message retention period means that the message will automatically be deleted in that much duration. Then maximum message size means that, in if I am saving the messages to the queue, what is the maximum size of the message that it's going to support. So like I said, please don't go and give big messages to that queue over there. Delivery delay is how much delay it is going to, if once you are sending the message back, how much delay is going to be there. Access policy, like you had already done inside your JSON, inside your IAM and inside your JSON, you can either create a basic method or a advanced. In advanced, like, you can go to IAM and you can create your own policy over there. Okay, so it can either be basic or advanced, in which case you go and write your own things. Right now, let's say basic, so only the queue owner can actually send the message. Now, in certain scenarios, like we have talked about roles or inside our S3 bucket where you can give access to other people, in that case, you can give access to others also. Either you go and give the ARN or you give the account number over there, in which case the access of the queue can also go to those people. Okay. Then if you want to enable encryption, you can enable encryption also. If you want a dead letter queue, it means the messages which are deleted after this 14 days over there, those messages will go to this dead letter queue. So dead letter queue in itself is a queue which is going to be like the graveyard queue of every message that has been there for more than 14 days and it has been deleted by the queue. If you want to add the tags, you can add that, like let's say name and the queue name, whatever it is, or let's say something like created by, and I can give some name over here and whatever things I want. So let's say machine and let's say backend or backend machine. Okay, and the moment I click on create queue, the queue will be created. Remember one thing, that the URL is there, so henceforth if you have to go and access that queue, that has to be on this URL over there. So in this case, if you have to go and get the details of any of the messages over there, you can go and get it from here. Also, if you have to, let's say, send the message to the queue, you can just go here and let's say, hi, message one, and you can say that, okay, you can send a message over there. So this message has actually gone to the queue. So it is showing you that two messages available. If you want to see the message, you can click on poll the message and it will show you that whatever messages are there. Now, if the message has not been received by anyone, you will see the receive count actually being increased. Okay, so if you click over here, hi, I am message one, this is one of the messages, the count is going to increase because no one has subscribed to it. Now, when I say no one has subscribed to it, the ideal way to do it is what you do is you go and you run a program which is going to go and listen to this message. And once the message is listened for, in that case, this particular program is going to go and tell the queue that, see, I have received the message, I have processed the message. Now you can go and delete the message. Because if you don't go and delete the message yourself, the message is going to remain there for whatever duration you have kept. In our case, it was for 4 days. So the message will continuously be there. After that, it either deletes or it goes to the dead letter queue based on the configuration. Now, actually, let's do one thing. Let's go to Lambda and have a look at how to go and manage the message from our Lambda. Okay, so what I will do is, let's go here and we'll create a new Lambda function itself, and that Lambda function is going to go and send the message to that queue. Okay, so for that we'll have to click on create function, and we'll have to do one more thing. You should remember by now that if Lambda as a service has to go and access another service, in that case you have to go and create a role. So I will go to IAM and I will create a role for Lambda over here. So roles and create role, and this has to be used by Lambda, and next permissions, and let's say here I'll have to select the permissions which Lambda can use, which in my case I'm selecting as SQS. Okay, so it can be read access also if you want, or full access. Tags review Lambda access SQS. Okay, and just go and click on create role. Now over here, let's go and start writing the things. So function name, let's make it like send SQS message, which is in this environment. That is fine. My role has been created, Lambda access SQS. So let's go to the role over here and use an existing role over here. And let's say Lambda access SQS and click on create function. So now if everything is good, so we will now go and start writing the program. Advantage of Node.js, as you know, is that in this case, you can straight away start writing the program over here itself. Now, if you have to go and work on SQS inside Node.js or any language, you will have to go and use the IDE. So let's go over here and start. So first of all, remove this complete thing. And what we will do is I will also open Lambda and SDK. Okay, or let's say if you want SQS SDK actually, so fine. So in this case, what I have to do, I have to just send a message. So I will go and either you can go and receive a message, which you can do that, or you can send a message or using this. Okay. So that's a message or that's a program that has to be used over here. So let's get started with our Lambda function. The basic things, first of all, line number 1, where AWS equals to require AWS -SDK, and then aws.config.update, and my region is set to AP South 1, and that should be it, or the important things which are there. And one important thing is module.export.handler equal to, let's call that message as send message. Okay, so obviously I will have to go and create a function over here by the name of send message, function send message, and this. So it is going to go and call this function, and that function is going to do certain things of sending the message. Now ideally, whenever you go and work on any of the SDK, always go to line number 1 over here and just blindly go and copy paste this as it is. So this part is done, where SQS equal to new AWS SQS, and now you have to send the message. So if you have to send the message, just go down and see send message over here and just copy the whole thing as it is, line by line, this part here, this, and just paste it. Now ideally remove the things which are not required. For example, message attribute, deduplication ID, this message attribute, and these things are not required, so that you can actually remove. So delay seconds not required. So how do you know? Whatever things it says required over here, those are the mandatory things, others are optional. So depending on the use case, you might want to have it or leave it. Right now, message body, let's say sending message from an Lambda, and the queue URL you need. So for that, I go over here and let's go to the queue, back to our queue over here, and the queue URL is something like this. Let's go and get that queue URL over here, this part. If it is error, let's put a opening bracket and a closing bracket. If it is successful, let's go here and do this. And in this case, I will say console.log data is there anyhow, and I will also say something like message sent. And if it is an error, I'll just write console.log error in sending message. Now that it's all looks good, let's go and deploy it first of all, and then let's just do it like this. Click on test, give some value, let's say test1 over here, and create. And if all is all good, click on test, and it should send the message to SQS ideally. If not, let's have a look over here. So what happens is it tamps out after 3.07 seconds, which means I had kept my Lambda function in such a way that it was only having the timeout for 3 seconds. So in that case, go down and you can increase the timeout over there. So let's go here and just let's make it 30 seconds, 0 minutes and 30 seconds. And remove this and test it out again. So now let's see, what does it say? Cannot read property handler of undefined. So basically in this case, okay, that's strange. Fine, let's have a look. It should have worked again. Anyhow, let's go over here and just see console.log sending message, and then let's deploy this part also. And let's test it out. At least I should see the result as sending message, which means it is calling that function at least. Okay, that is itself not being called. Fine. So which means that this thing itself is not being called over here. So let's say module dot exports. Okay, can you find the error over here by any chance? So the error is that exports dot handler. So now if everything is good, the message should be sent, and anyhow you can go over here and you can click on send and receive message over here, and ideally if everything is good you should see the message over here, poll for message, and the message, whatever the message was, hi I am message one, and then this message something like this, and then this message sending message from Lambda. Okay, now let's go and just change the message. So sending, this we don't need sending message from Lambda. This is message -1. Click on deploy over here. So just pay attention to these small things. Like in this case, I just had to do exports and not export. So test over here, and if everything is good, it should go and get the fourth message. Also have a look at the time over here, the latest time. So you click over here and it says this is message one. So that's a message, basically whatever was sent and the sender account ID and how many times it has been received. Because I'm not sending any attributes. If you want to go and send any attributes, you will find it over here inside message attributes. You can send it. So whatever type of value you want to send. But in ideal cases, this should help me, because in this case I had to just send something, and this is what I'm sending. So if in case it's an email ID, you can go and send something like, let's say ankit@abc.com, something like that. Click on deploy over here and then test it out, and then your other code is just going to go and listen to that message over here. So let's just wait for it. So so ankit@abc.com. So you basically, the concept is that queue can be used to send a message. Now in ideal cases, you don't read the message from your console over here, rather you read the message from your another program. So if you understand this now, what I am doing is each time I have to go and do a test on top of it. So basically that is the way how it works. However, there are other ways of doing it, and that is that if you are clicking on test, you don't have to do it honestly each time. Rather, the same way you are sending a message, you can also go and receive a message. Okay, so let's have a look at that function, and that you can do on your own. So you can go and subscribe to that message, or you can go and listen to that message. Okay, so list queue, these queues, get message, get these all things are there. So in that case, if you want, you can go and listen to the queue over here, receive message. So in that case, what happens is only this part is important, queue URL. Rest all, if you want, good. If not, that is also fine. Where params queue URL, and it goes and receives the message. Now after you receive the message, you go and hit this part over here. Now what you do inside that depends on. Okay, so that is another way to go and work on queue. So basically this itself is part of a program, and what we do is that we create something as a batch job. So the concept is that every 30 seconds or every 5 seconds the batch job is running, which is going and running this program itself. So every 5 seconds it goes, looks into the message. If any message is there, picks it up. If no message is there, that is fine, it tells you that. Okay, so this is how SQS works. And basically if you understand SQS, and basically if you understand IAM and your Lambda, you can work on any of the services of AWS. Okay, so IAM, Lambda, and SDK, so you can get it from anywhere. It can be SQS, it can be S3, it can be EC2, whatever the thing is. So I know that a queue is there. I can go and send a message to the queue. My Lambda function is also there. But then the thing is that how much is it going to charge me? So charging for that sake, if you have to go and send a message, so you can go for AWS Calculator, which should always be the first thing that you ever see inside AWS. Okay, so to know calculator, anyhow, it's not important to know AWS. Even you can just go and create an estimate. So let's go and see a calculator. So let's click on create estimate, and the service I am interested in right now is SQS. Now please remember one thing at least, that you are publishing only 10 messages to the queue. okay, in the whole month. However, you are listening to the message every 5 seconds. So you are doing those many operations. What do I mean? If you are asking the queue to send you a message every 5 seconds, or you're just going to the queue and hitting the queue every 5 seconds, that is also counted as an operation. Okay, so here the concept is every 5 seconds you go. So in a minute you go 12 times, in an hour you go 720 times, in a day you go 720 into 24 into 30. That's for the whole month. So keep that thing in your mind. It's not that it becomes only 10 messages. Whatever you are going and asking the queue, do you have a message? If you have sent it across to me, that is also counted as a message. So let's say I am going for a standard queue 1 million per month, FIFO queue 1 million per month, and same thing, I am having it from the internet and 1 terabyte, and I am transferring it to, let's say, CloudFront or internet, which is again 1 terabyte per month. So have a look at the price over here. In this case, your standard queue will charge you 40 cents, your FIFO queue will charge you 50 cents. So it doesn't look that great, but the moment you go and make it more messages, because if you are sending a million messages itself per day, in that case it becomes 30 million here and become 30 million over here. Then again, just sending a million messages in itself doesn't mean that it is only 1 million, because every 5 seconds or 10 seconds or whatever frequency you have sent, you have set over there, you are going to poll for that message at that duration. Okay, so it becomes a big number. Let's for a general scenario, let's count it like 100 billion messages a month, which is a general use case. So in that case, you end up with this much, $900, and the pricing is $400 for this and $500 for this. So 100 million is also a big number, yes. So that's the case. You know the price differencing also. Now FIFO is somewhat more than your standard queue, and how much different? Exactly 1.25 times different, or let's say 25% expensive as compared to your general or your normal or your standard queue. So this is how you can go and give your estimate. In this case, let's say I'm preparing it for a client, and so let's say something like uh, message business for client, and let's give the name over there, whatever it is. So in that case, this is my estimate. Click on add to my estimate. Once everything is done, they will tell you that for 12 months you will be charged this much, in which case you can click on save and share. So you can copy this public link over here, and now if you go and paste it anywhere, or if you send it to them also, it will directly show up your estimate only. So this is a way by which you can tell anyone that how much AWS estimate is going to be. Now please remember that this estimate is editable if you want, and they can also go and change it. So that's the anyhow the whole point of using AWS and cost calculator, that you can go and create an estimate, and anyone else can go and they can also change, or they can have a look at what the estimate is. So it's all clear basically. It's not like you are saying something and they are getting something else. Okay, so this is a part of the queue which you have seen. Now one last thing to see inside a queue, that if you go to your queue over here and you click over here, for any of the things, you will always understand that you can go and call a Lambda message anyhow. You dead letter queue, understand, you can create a dead letter queue, which basically becomes the queue where the messages will go if at all the messages are deleted from this queue after duration of 4 days. Okay, so if you enable it, that enabling itself is going to be a queue. Okay, so in ideal cases, what you can do is you go to a queue over here and you go and create something like a DL queue, a dead letter queue, and the message retention you put as complete 14 days, and you click on create queue. So this queue, dead letter queue or DLQ, is going to save any messages from any of the queue if it is not delivered. So let's configure it. I click on Q1 over here. I click on dead letter queue. I click on edit over here. And finally this I enable, and I give my queue, which is DLQ over here. So, and I click on save. Now if at all this message isn't delivered or received by anyone for the next 14 days, in that case this q1 is going to go to your queue named DLQ, where again after, because DLQ itself has a timeout of 14 days, expiry of 14 days. After that, yes, it is anyhow going to be expired. Now one interesting thing is your monitoring over here. Let's have a look at that. Monitoring basically is your same CloudWatch monitoring. In this case, you can go and have a look at your various consoles or various things that your queue is doing as of now. Okay, so because I started it sometime back only, so right now it looks like this, but let's go and make it something like 1 hour. Okay, or maybe even let's make it for the last 15 minutes only. Okay, so you can see that a or approximate age of the oldest message, it is telling me of the message if any delay happened, if the message not visible, because now what happens is all the 5 messages have increased the timeout. So what do I mean by that? You go to edit over here, and I had put a timeout over here. So visibility timeout after 30 seconds. So now all the messages are not visible to me. Not visible to me does not mean the message is deleted. It's just that they won't be visible to you upfront over there. And the reason for that is you always want to see the latest messages only. That is why this is. So earlier it was somewhat, and then straight away it went to 5 over here, and then again it went to 0 because everything is there. So how many messages were visible earlier? It was somewhere near to 1. Then now we have 5 messages because we had sent those many messages. And these basically are your CloudWatch metrics, which are visible to you. This can also be seen from your queue. This can also be seen from your service of CloudWatch over here. So let's go for CloudWatch. So if I go to metrics over here, and in that case, I can go and search for my queue. So this CloudWatch is going to show you all the services that you have ever worked on. So in case if it shows you only 1 or 2, the reason is that you wouldn't have worked on all those services as of now. The moment you go and open any one of them and it works, you will also start to see that things also. Okay, so in our case, you want to see SQS. So I just open the dashboard, and ideally I will see the same things that I saw inside my queue over there. Okay, now you want to see it for last 1 hour, last 3 hour, 12 hours, and so on. You can do that. It can go on up till last 15 months over here. Also, it can be in local time zone, it can be in UTC, whatever time zone you want, it can be in that. Okay, local time zone is the time zone that you are in right now at that moment. Okay, so that's the concept of SQS. And then we have also seen how to apply some amount of pricing to it by going for AWS Calculator. And we have also seen CloudWatch. Let me just go and give you one example of AWS Calculator again. And let's start with the basic example. Let's say that your friend has an ice cream business, and they process approximately 1,000 orders a day. Okay, so in that case, they need one backend machine, which will be a machine which will have better backend, so a compute machine. They need a front end machine, which is our S3, or it can even be my EC2 instance having Apache server, and they need a database, which is going to be a compute heavy machine. Okay, so if I have to create the estimate for them, let's go and take this example and see how much estimate it's going to cost them. So estimate over here, and then I click on EC2 and I click on configure over here. The servers right now, I am just going and placing it inside Mumbai because of the latency, which will be low. So fine. So I'm going for a Linux machine and I'm searching it by name. Now I need a instance for the front end. So I will right now go for, let's say, T4G dot medium, because it's a 2 CPU, 4 GB machine, and that is fine for me. This quantity is there, fine. And I want to go for 1 year plan over here, and I'm paying everything upfront, and I will need 30 GB storage. So in that case, it will cost me $115. $115, by the way, is for the whole year. Now, ideally, it's always advisable to go for 3 years. We will see that it becomes $215. And then let's go, if you want, you can go and add another service also. So in that case, let's go for EC2 again, and Mumbai, and in that case, instance by name. Now I said one front end machine, which I have done. I need a backend machine. So backend machine, I can take a burstable machine, because I know the business is going to go up and down. So in the night time from 6 to 10, I will see a heavy load. In the lunch time 12 to 2, I will see a heavy load. So in that case, you might want to take a burstable instance. So let's take a T3, a large in this case. Large is 2 CPU and 8 GB of RAM. In that case, again, I'm taking for 3 years over here and I'm paying everything upfront, and 30 GB I'm making it and I'm add to my estimate. Okay, so 2 machines have happened. That is fine. And I need one more machine, and that machine is going to have my database. So right now I'm just assuming my database is going to be Apache Cassandra, and that Apache Cassandra is going to work on a compute machine. Okay, so here I need a better compute machine. So I go for a C5A, and I go for, let's say, X large, 4 CPU and 8 GB RAM. So 4 CPU, 8 GB RAM, it has bandwidth up to 10 Gbps, and it's a compute machine, so it's going to be pretty fast on the computation part. Again, I'm paying all upfront, full upfront over here, 30 GB. Now, because this is database, I will need more database. So instead of going for GP2, I will first of all go for GP3, and I have this much speed, and let's say I'm going for 1000 GB initially. That is costing me $919. Add to my estimate, total is $2787 for 3 years. So for 1 year, it will cost you $929, and for 1 month, it is going to cost you approximately $70. Okay, so or divide 2787 division 36. So let's do that. So 2787 division 36. It is going to cost you $77, and if you have to calculate it in this Indian currency, it is going to cost you approximately 6,200 rupees. So in this case, now if you have to tell your friend, you can tell them that okay, it's going to cost you approximately this much amount. Now if they want to go and change it, they say that okay, I don't think that I will need that big machine. So ideally the clients are not going to come back to you because you are the one who decides. But we already have thought about the things that database is going to go for a compute machine. So that is why I went for C. My backend, a burstable one. That is why I went for a T series over there, T3 a large. And my front end is going to be pretty small. So just a website over there. So I have put this particular instance over there. Okay, so this is how you go and create the estimate. You can click on save and share, and this link is there. You can copy it and done. That's how you go and create your estimate inside AWS. Okay, so yes.